Alrighty guys, welcome back to office hours. So now we are going to work on the problems for division. If you are from my third period class, I get to clarify some concepts that I didn't get to in class. So here we go. So for division guys, for scientific notation, it takes on the quotient rule from the law of exponents in math. So in math, for law of exponents, so they basically say if I have a number to an exponent divided by a number with the same base to an exponent, what I get to do is take that number with the same base and I just subtract their exponent from the top from the exponent, or minus the exponent on the bottom. So in math, I learned this by subtracting, going top to bottom always for law of exponents. So here we go. I have the steps written out as always from our notes. So for the first one, I have 4 times 10 to the 6th divided by 2 times 10 to the 4th. So what I do is I divide the numerator by the denominator. 4 divided by 2 is just 2. And then I take the exponent from the numerator and I subtract that with the exponent in the denominator. So here I have 6 minus 4, and I'm left with 2 times 10 to the 2. For this next one, and this next one I did in third period, and I had about a minute left, and I did it really fast, and I accidentally flipped the exponent. So I have 3 times 10 to the negative 6. I'm going to show you guys the proper way to do this calculation. All right, so I have 3 times 10 to the negative 6 divided by 2 times 10 to the negative 4. I know 3 divided by 2 is equal to 1.5. This number is between 1 and 10, so it gets to stay. And here, since my bases are the same, I just subtract these exponents. So remember, from the quotient rule from math, since they have the same base, all I have to do is take the exponent from the numerator minus the exponent from the denominator. So here I have, let's see, negative 6 minus, and then here I have negative 4. I know here that 2 negatives make a positive, so this actually becomes negative 6 plus 4. So I'm actually left with 1.5 times 10 to negative 6 plus 4 is negative 2. And this is my answer for that one. All right. So here I have 3 times 10 to the 7th divided by 8 times 10 to the 4th. So let's see. I'm going to pause the recording really. All right, I'm back. I got a calculator. So I have this. I have 3 times 10 to the 7th divided by 8 times 10 to the 4th. What ends up happening is, so I have 3 divided by 8 is going to be 3.375. And then I have times 7 minus 4, 10 to the 3rd. But wait, do you guys remember that I'm supposed to have the format a times 10 to the n, where a is a number between 1 and 10? So here, I know that 0.375 is less than 1. So what I'm going to do here is I'm going to move the decimal over to the right. So I have 3.75. Since I moved it over to the right, I have to take 1 away. from there. So I have 3.75 times 10 to the second power. This actually checks out. So if we move the decimal place over 3, 1, 2, 3, you get 375. Here, I move the decimal place over 2, 1, 2, and this is also 375. So this checks out. All right, the last question for the multiplication one is, let's see, I just lost it. Aha, there it is, okay. Is 7 times 10 to the negative 5 all over 2 times 10 to the 10th power. So what I'm going to do is I have 7 divided by 2. Well, I know 8 divided by 2 is 4. So this one's going to be 3.5 times 10. Since my bases are the same, I know that the law of exponents applies. But I have negative 5 on top and 10 on the bottom. So I'm going to pull back out my formula for that. And since I still have a base 10, I can still subtract them through. So I have negative 5 minus 10. And that leads me to negative 15. So my exponent here is actually negative 15. And I'm left with 3.5 times 10 to the negative 15, which is a really, really tiny number. So with that being said, everything in a box is the correct answer. And those are the answers for the division examples. Okay, now I hit, oh, there it is.